So let's recap here. Learning target 4, Milankovitch cycles or M cycles. These are changes with the Earth and Sun relationship. So in our discussions and activities, we went over 3 big things that we saw really impacted with the Earth and therefore how the Sun impacts the Earth. So you got some keywords to use over here: orbit, tilt, Sun, Earth, and ice. I got you started here, changes to the Earth and Sun relationship, and we already have 2 of those keywords there, so we can get those highlighted and ready to go. There are 3 different changes that we looked at. One was the angle of the Earth's tilt, so that was our big one. We also looked at the orbit shape, and finally we called it the wobble of Earth, which is essentially looking at the tilt direction. So each one of these has an extreme to its condition and a less extreme to its condition. So we're going to break down each one in a quick recap, and then I'll help you get details on your 2 and your 3. So keep in mind your keywords. Again, we've already got a lot of them used. I am not going to come back to this view. I'm going to just work in the slides and the visuals. So I will give you a heads up when information for 2 and 3 comes about, but make sure you are filling this in as you go. So now might be a nice time to go half screen and be able to write as we're talking. So just a quick recap on the 3 changes. The first one, like we said, is a change in the tilt angle. So extreme and less extreme. So we can go very big in tilt, or we can go very small in tilt. Now, when we have a greater tilt, that's when the sun's energy hits more direct on the poles. This is our extreme seasonal change. So we typically see more ice melt during that larger tilt, again, because the solar energy can reach all the way to the poles for a longer period of time. When the Earth is in its lower tilt phase, that's when we have less extreme, and that's when we see ice either stay put or really be able to advance and grow. Okay, so just a reminder of what's going on with tilt. Here with change in orbit, we had 2 shapes that we were differentiating between: circle and ellipse, which is, remember, like an oval shape. Again, one has a more extreme situation and one is less extreme. The ellipse is our extreme, again, causing ice to melt because within that elliptical shape, we get periods of short distance and long distance. So extreme, essentially thinking about the seasons being more varied. So during this time of closer proximity, we typically see the ice melt. When we're thinking circle, then everything is more consistent. So that is the best time to grow ice because everything stays stabilized throughout the course of the year. Finally, the last one, like we said, was called wobble. Okay, now we're looking at a change in tilt direction. And this one doesn't so much have an extreme or less extreme, but it's just a varied time of when the season would occur. So currently in our January months, that's when we're tilted away from the sun. So we, of course, have winter. But as the Earth flip-flops itself and this cycle works its way through, at one point in time, January is when the Earth tips towards the sun, and that would then be our summer months. Okay? Now, there is a slight variation on distance from the sun, and so that small impact can also have an impact on the extreme or the variety of temperatures we see in the season. So big picture, each one of those changes has an extreme and a less extreme. And all of those are impacting the global ice. So this is really what we're focusing on for our learning target number 2. So this is where you want to be ready to write in your learning target number 2. Certain conditions create those extreme or varied seasonal changes. And when we are in those extreme conditions, that's when we see time of ice melt. So again, we mentioned the extreme being the ellipse and also the greater Earth tilt. Now there are certain conditions where they are more consistent throughout the year, giving seasons less change in between. That's when we see times of ice growth. So again, these two statements would be perfect for your number 2, as this is our M cycle impact to climate. Parts of the seasons or parts of the cycles melt ice and parts of the cycles grow ice. And finally, our number 3. Oops, my bad. Here we go. Finally, our number 3. What is the evidence to support these ideas? Well, here's what we know. Individually, each one of these has a small impact to the Earth. However, when we look at each individual data set and start to recognize when these align, that's when we really start to see the large impact causing global climate impacts. Major times of ice growth, like ice age, and major times of ice melt. So again, individually, each one of these cycles does not have an overarching impact on the globe, but when the elliptical shape aligns with the extreme orbit, aligns with the furthest distance for winter, that's when everything starts to click and all the data together looks pretty familiar. This is very similar patterning to our 800,000 years Antarctic CO2 data. We're seeing the same trends now as explained by these Milankovitch cycles. So this is your number 3. Alone, they don't have a huge global impact, but together, when they all align, we see major changes in the Earth's climate, times of growing ice and melting ice. So you should now have both your 2 and your 3 filled in, making sure any use of your keyword gets highlighted along the way.